Hello everyone. Today I am going to discuss about an electrical circuit configuration which is a part of BJT. So now what is a BJT? BJT or bipolar junction transistor is a three-terminal device which is used for amplification of weak signals and also used for switch operations. There are two types of BJT which are NPN and PNP. On basis of these two types, there are several BJT configurations. We can see like fixed bias configuration, ammeter bias, voltage divider, collector feedback configurations, and so on. So here I am going to discuss about how to solve a collector feedback circuit configuration in an easiest way. So what is the specialty of this configuration? The collector feedback configuration helps to keep the transistor in the active region. This is done because the bias voltage can get changed if the input and the bias voltage is superposed. So here now a collector feedback circuit is given and their equivalent resistors RC, RF and RE also given. We need to find IB, IC and VC from this circuit. Here we can see the collector terminal current is divided at the VC point and one branch goes through the feedback resistor which is RF and also which is base current IB actually. Another branch IC goes to the transistor. So to solve this we will follow a four-step solutions which will make the circuit simple. First we need to make DC analysis ready, which is nothing but to remove all the AC with terminals if there is any. So we can see we remove the extra capacitors which was there before. In the second step, we will connect the VCC or our battery sources to the ground. Here we will create an input and an output loop with voltage source VCC. The left portion is our input loop and the right side is our output loop. Rest of the circuit will remain same. And here comes our third step, which is input loop. We will now individually work with our input and output loop. First, let's consider the input loop. Here RC, RF, RE resistors are given. VRF is the voltage across feedback resistors RF. VBE we know for silicon diode which is 0.7 volt. We set the polarities now in the circuit in order to apply our Kirchhoff's voltage law equal to 0. We can see this loop works clockwise. Since the battery voltage is positive through the clockwise. And now if we replace the voltage with our Ohm's law, we can write that as IC prime RC, IB RF, and VB we will remain same, and here IE and RE equal to 0. So here we put IC prime because we can see here IC current is divided through the VRF and VBE. So for the moment we consider the current through the VBE is IC prime. So let's put the value now kilo ohms is equal to 0. So since there are three unknown variables, we can't solve it right now. So let's for the moment name it equation 1. So now for the output loop we will considering the output loop, we will again apply our Kirchhoff voltage law. Sorry, the output loop. And now we can see this will work as anti-clockwise, so equal to 0. So right now here is also three unknown variables, so let's keep it as equation number 2. So now, to help us with our problem, there is an independent variable given which is beta, and we know beta is equal to IC by IB, and here beta is given as 120. We can write it as IC equal to beta into IB, and beta is 120 into IB. So you can see IC equal to 120 IB. So let's keep it as equation 3. We can use it later. And we also know that IE, emitter current, is equal to IC plus IB. And here we can see IC prime is equal to IC plus IB. Since IE is connected with the ground, so we can see that IE is equivalent to IC prime. So we can write IE is equal to 120 IB plus IB. Just replace it with IC. Which is equal to 121 IB. So now we will use these values in equation number 1 to find IB. So let's use the equation 1. From equation 1, 0.01798 milliampere. So we can also write it as IB equal to 17.98 microampere. Just to multiply it with 1000. So we find one variable which was asked for. Now we know IB. So since we know IB, we can also solve for IC. So IC equal to will be equal to just equation from 3, 120 into 0.01798, and IC gives us approximately 2.16 milliampere. And now we know IC also. Now let's solve for IE as well, because it will be needed later. IE is equal to 121 IB, and which we know 121 IB is 0.11798, and which gives us 2.18 milliampere. Okay, so now we know IE as well. So now, in order to find BC, we need to solve for BCE. So let's now find for BE, which gives me with the if we apply Ohm's law, IE RE, and we know both of them, which is IE is 2.18 into RE is given 1.2 kilo ohms, and which is 2.62 volts. Okay, so now we can find BCE very easily from our equation number 2 actually. So let's find BCE. It's already applied in the Kirchhoff's voltage law. Okay, so now we also know BCE as well, and this is VE. So from this we know BCE is equal to BC minus VE, and BC is BCE plus VE. Now, since we both know both of them, let's just put their values plus 2.62, and then BC equal to 8.5 23 volt. And this is the way we can solve this configuration very effectively. And thank you everyone for watching.